The National Electrical Code, often abbreviated as NEC, considers the service entrance to be the connection point between the utility and the building's electrical system. The NEC stipulates that the service entrance must be protected by a service entrance device. This device is either a circuit breaker or a fuse, and it needs to be rated for the electrical system's full load. When a standby generator is added to an existing facility and the plan involves cutting the service entrance conductors between the pad mount transformer and the main distribution panel, and then bringing those conductors into a transfer switch for the standby generator, the transfer switch effectively becomes the service entrance device for the generator. As a result, the transfer switch must be rated for the full load of the electrical system, including the load contributed by the standby generator. Using a service entrance rated transfer switch is essential. Firstly, it ensures that the electrical system is adequately protected in the event of a power outage. Secondly, it complies with the NEC regulations, which are designed to protect people and property from electrical hazards. Let's delve deeper into why this requirement exists and what it entails. A service entrance rated transfer switch is designed to withstand the stresses and potential hazards associated with being the primary point of connection to the electrical grid. This includes handling high fault currents, providing overcurrent protection, and isolating the building's electrical system from the utility grid during a power outage. Firstly, fault current protection is paramount. A service entrance rated transfer switch is built to handle the high fault currents that can occur during a short circuit or ground fault. These currents can be several times higher than the normal operating current of the electrical system. If the transfer switch is not rated to withstand these currents, it could fail, leading to equipment damage, fire, or even personal injury. Secondly, overcurrent protection is vital. The service entrance device, whether it's a circuit breaker or a fuse within the transfer switch, provides overcurrent protection for the entire electrical system. This means that it will trip or blow if the current exceeds a safe level, preventing damage to wiring, equipment, and the transfer switch itself. Thirdly, isolation from the grid is critical during outages. During a power outage, the transfer switch isolates the building's electrical system from the utility grid. This prevents backfeed of power from the generator into the grid, which could endanger utility workers who are trying to restore power. The NEC mandates service entrance rating for transfer switches in these scenarios because it recognizes the critical role they play in protecting the electrical system and ensuring safety. Without a service entrance rated transfer switch, the electrical system would be vulnerable to a variety of hazards, including electrical fires, equipment damage, and personal injury. To further understand this requirement, let's consider the specific aspects of selecting and installing a service entrance rated transfer switch. 1. Determining the load requirements is a crucial first step. The transfer switch must be rated for the total load of the electrical system, including the normal load and the load of the standby generator. This requires a thorough load calculation to determine the maximum current that the transfer switch will need to handle. 2. Selecting the appropriate transfer switch type is important. Transfer switches are available in a variety of types, including manual, automatic, and bypass isolation switches. The choice of transfer switch type will depend on the specific needs of the facility and the level of automation desired. 3. Ensuring proper installation is critical. The transfer switch must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. This includes proper wiring, grounding, and bonding. 4. Performing regular maintenance is essential. The transfer switch should be inspected and tested regularly to ensure that it is functioning properly. This includes checking the operation of the transfer mechanism, the condition of the contacts, and the tightness of all connections. Let's elaborate on each of these aspects. Firstly, load calculations must be performed accurately. Load calculations involve determining the total current draw of all the electrical equipment that will be connected to the system. This includes lighting, appliances, motors, and any other electrical loads. The load calculation should be based on the nameplate ratings of the equipment or on standard load factors specified in the NEC. Secondly, transfer switch types offer different functionalities. Manual transfer switches require manual operation to switch between the utility power and the generator power. These are typically less expensive, but require someone to be present to operate the switch during a power outage. Automatic transfer switches automatically switch between the utility power and the generator power when a power outage is detected. These provide a more seamless transition and are often preferred for critical applications. Bypass isolation switches allow the transfer switch to be bypassed for maintenance or repair without interrupting power to the load. These are typically used in critical facilities where downtime is not an option. Thirdly, installation must adhere to the NEC and manufacturer's instructions. Proper installation is crucial for ensuring the safe and reliable operation of the transfer switch. This includes using the correct wire size, properly terminating all connections, and providing adequate grounding. The installation must also comply with all applicable codes and regulations, including the NEC and local building codes. Fourthly, maintenance ensures continued reliability. Regular maintenance is essential for keeping the transfer switch in good working order. This includes inspecting the switch for any signs of damage, cleaning the contacts, and testing the operation of the transfer mechanism. Maintenance should be performed by a qualified electrician. In addition to these considerations, there are some specific NEC articles that are relevant to the installation of service entrance rated transfer switches. NEC Article 230 covers service entrances, including the requirements for service entrance equipment. NEC Article 700 covers emergency systems, including the requirements for standby generators and transfer switches. NEC Article 701 covers legally required standby systems, which are systems that are required by law to have a standby power source. NEC Article 702 covers optional standby systems, which are systems that are not required by law to have a standby power source but are installed for convenience or business continuity. These NEC articles provide detailed guidance on the installation and operation of service entrance rated transfer switches. It's important to consult these articles to ensure that the installation complies with all applicable requirements. Choosing the right transfer switch also involves considering its interrupting rating. The interrupting rating is the maximum fault current that the transfer switch can safely interrupt. The interrupting rating must be greater than the available fault current to the service entrance. This information can be obtained from the utility company. A higher interrupting rating provides a greater margin of safety and can help to prevent damage to the transfer switch in the event of a fault. The withstand rating is another important factor. The withstand rating is the maximum fault current that the transfer switch can withstand for a specified period of time without being damaged. The withstand rating must be greater than the available fault current at the service entrance. A higher withstand rating provides a greater level of protection against damage from fault current. When selecting a service entrance rated transfer switch, it's also important to consider the environmental conditions in which it will be installed. If the transfer switch will be installed in a harsh environment, such as a dusty or corrosive environment, it may be necessary to choose a transfer switch that is specifically designed for those conditions. Transfer switches are available with a variety of environmental ratings, such as NEMA 3R for outdoor use and NEMA 4X for corrosive environments. Also, the control features of the transfer switch are critical to consider. Transfer switches are available with a variety of control features such as automatic transfer, manual transfer, and remote control. The choice of control features will depend on the specific needs of the facility. Automatic transfer switches automatically switch between the utility power and the generator power when a power outage is detected. Manual transfer switches require manual operation to switch between the utility power and the generator power. Remote control allows the transfer switch to be controlled from a remote location such as a control room. Furthermore, consider the future needs of the facility. When selecting a service entrance rated transfer switch, it's important to consider the future needs of the facility. If the facility is likely to expand in the future, it may be necessary to choose a transfer switch that is sized to accommodate the future load. It may also be necessary to choose a transfer switch that has the ability to be upgraded or expanded in the future. In summary, using a service entrance rated transfer switch is not just a suggestion, It's a requirement enforced by the NEC. This requirement ensures the safety and reliability of the electrical system. By understanding the reasons behind this requirement and the specific considerations involved in selecting and installing a service entrance rated transfer switch, you can ensure that your facility is adequately protected in the event of a power outage. Remember to consult with a qualified electrician or electrical engineer to ensure that the transfer switch is properly selected and installed in accordance with all applicable codes and regulations. This will help to prevent electrical hazards and ensure the safe and reliable operation of the electrical system. Always prioritize safety and compliance with electrical codes. A properly installed and maintained service entrance rated transfer switch is a critical component of a safe and reliable standby power system. Remember that failure to comply with NEC regulations can result in fines, penalties, and even legal liability. Therefore, it is always best to err on the side of caution and ensure that all electrical work is performed by qualified professionals who are familiar with the NEC. By taking these precautions, you can help to protect your property and the people who use it from electrical hazards. The information presented here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. Remember to always check with the authority having jurisdiction for final approval.